Good afternoon, Tigers. So today we're going to be working with scatter plots and drawing a line of best fit and writing an equation to use the equation for prediction. That's really important. What I just said is that we're going to be using the equation. Now my points just moved. We're going to be using the equation in order to make a prediction. And so we want to make sure, let me move my graph there, make sure all my points are nice now that I've had to move it a little. So 2018, yes, we are good now. Okay, sorry about that, delay of game. Then we will use the equation to predict the time to travel 32 miles on a bicycle. So we're going to draw on our line of best fit. We're going to calculate the slope. We're going to use point slope in order to write an equation, and then we're going to change that into slope intercept in order to use the equation to make a prediction of, in this case, how long will it take to travel 32 miles. So that's what we're going to be working with today. So as you can see, I've already plotted the points on the graph, and you can go ahead and pause the video and do that yourself. I want you to understand that when I see a graph, a table that is written horizontally, then my X is always on the top and the Y is always on the bottom. 527 is an ordered pair, 1046 is an ordered pair. You get the point. All of these are ordered pairs that I have plotted on to my coordinate plane. Once I have all of the points plotted on the graph, then I am going to draw in a line of best fit. You guys have already learned a little bit about this. When I draw in my line of best fit, the line has to touch 2 points and it has to go through the middle of those points. And one thing that you want to think about is that you don't want to just use the first point and the last point, because if you do, then you're really not considering all of the points in between. It is okay to use the first or the last, but you definitely don't want to just use both of those points. When I draw my line has to touch at least 2 points. And I can kind of see that as I'm going through this, that it's really going to kind of go through my top point and then sort of this other 1046 point. Now your line could be in a little different place, and that is perfectly okay, because really what we need in order to make this a successful graph is a correct slope. And so I want to say, okay, well, my point went through this last point, which was the 22,107, and then it also went through the point 1046. And so I'm going to use the points that my line went through in order to calculate the slope. Doesn't that make sense? Don't just randomly choose 2 points, because, for example, if I use this second to the last as 1878, right here, that 1878 really isn't part of the line, so that's really going to affect my slope in a not a mathematical way. And so we want to make sure that we're calculating the slope with our line. So you know the formula when I'm calculating slope, that's going to be y2 minus y1 all over x2 minus x1. So let's go ahead and calculate that then. I'm going to say this is my y2 and my x2. This is my x1 and my y1. That's going to keep my numbers positive to start with the larger numbers. So I've got y107 minus 46 on the top, and I have 22 minus 10 then on the bottom to calculate my slope. When I do that, I end up with this 61,112. Well, you guys, that is so close to 5. That is actually 5.08. I'm just going to call my slope 5 for this equation. Once I know my slope, then I need my equation of point slope. Remember, y minus y1 is equal to m times x minus x1. And then I can use either of those points. It really doesn't matter. I'm going to choose the point that was smaller, which was the 1046. But once again, once I use point slope, you guys know that once you've distributed, you end up with slope intercept, and then you're going to use the slope intercept formula in order to calculate or make the prediction. So either way is fine, but I'm going to go ahead and use the 1046. So I have y minus 46 is equal to 5 times x minus 10. From here, we know to distribute the 5. And then the last step is to get rid of the negative 46, which means to add 46 to both sides of the equation. And I end up with y is equal to 5x, and that's going to be minus 4. Now that my equation's in slope-intercept form, I can use the equation to make a prediction. Remember the original question. We're going to use the equation to predict the time needed to travel 32 miles. So I can kind of make an estimate. I could continue my line up here. Obviously, if it was a straight line, I could do that. And then I could think, okay, well, that would be 30, and then 32 would be approximately there. But sometimes the numbers are so far off that you can't even really do that. So we want to be able to use a method that's always going to work for us. The question is 32 the x or is 32 the y? That's something that you should be thinking about right now. Well, I hope you made a decision on that. The 32 miles is our x, and so when I go back to use the equation, y is equal to 5x minus 4, then of course I need to substitute in the 32 for the x. So y is equal to 5 times 32 minus 4. That is going to give me 160 minus 4, or y is equal to 156. And as you can see, that kind of does jive with our original problem and where the line would go, because this would be 120 and then 130, 140. So it's approximately in that vicinity. If you were to get something like 120, then you would know that you were off, because 25 we were really close to 120 just in our original number here with the 25. So just something to consider. Make sure you know how to use the equation. Now this problem is going to be a little bit more challenging just in terms of, well, we don't have an appropriate scale, so we're going to have to determine an appropriate scale in order to make some predictions. So I know that this is x, my height, and then my weight is going to be y. So I'm going to go ahead and label my coordinate plane. That's to start with. Height in inches and weight in pounds. Okay, now once I've done that, I can see that my height, all of these numbers are really close together. My lowest number looks like is 64, and my highest number is 74. So I need that information in order to determine an appropriate scale. The problem is that if I do a broken interval, then my y-intercept is always going to be off. And so I'm going to just make the best of it. And I understand that a lot of my graph is going to be between a few lines. But again, if I ever need the y-intercept, then it's a really important thing to remember that I can't use a broken interval. So I wouldn't, at least for scatter plots. So 0, I'm going to go ahead and kind of count every other line here. I'm going to clean this up right here with this 30. Okay, and then as far as going up the scale, those numbers are a little bit more spread out, but I noticed that my lowest number is 152 and my highest is 190. And so I'm just going to count by 20s, and I'll just count every other line. The scale, notice it can be different varying from your x to your y. It does not have to be the same, but it does have to be labeled. Once I have an appropriate scale, then I can go ahead and plot the points. Now this one's going to be a little different because notice that the numbers aren't in order, but still this is an ordered pair. 71, 170 is an ordered pair. 68, 160 is an ordered pair, so on and so forth. So I want you to pause the video right now and go ahead and plot the points. When you're finished, you need to start the video again. All right. right, hopefully you've plotted your points. And as you can see, again, the points are sort of clustered together. I also went ahead and drew in the line of best fit so that um, you could see where that should be approximately. Again, your line might touch different points as far as the stipulations for drawing in the line. Make sure you're using a straight edge. Your line should touch at least 2 points, not the first point and not the last point, not both of them, but it can touch one or the other. And sometimes it can touch more than that. That's entirely okay. And we're talking about height and weight here. So as far as if my height is 0, then my weight is 0. So that's kind of where we started. And I just sort of use that point as a guide when I work through my points as well. And so that's a good idea. And so we know that this is going to be a positive correlation, or it's not going to have any negative coordinates. Does the scatter plot show positive, negative, or no correlation? Well, it's going to show positive. So we can go ahead and fill that in here. State the relationship between the height and the weight of the basketball team. I would say, and we usually start with the X and then talk about the Y. So I would say as the height increases, the weight increases. Could we also say as the height decreases, the weight decreases? Of course we could, and that's why it's a positive correlation, because both the X and the Y are going in the same direction. Both are increasing or both are decreasing, just depend on how you look at it. It says predict the weight of a player that is 72 inches tall. And so I can look at this graph and I can see, following approximately, if I'm at 72, then I'm going to be here right next to the right of 70. Predict the weight of a player that is 72 inches tall. Let me actually pull out a line. So at about 72, then that's going to go up to the line at approximately that point, which I would say that's about almost 180, maybe about 178. So from this particular graph, we can make a prediction, but you know I'm going to make you use the equation because that's what the point, we've got it to, in order, we have got to create the equation so that we can really make a good prediction. As far as my original line, I would say that my original line went through what, 70, where are we, 71, 170, 71, 170. And then it also, and don't think, that's not the first point. The first point would be this point. So I could say it actually went through that point and it went either through this point or I could use that one, either one. I'm just going to choose this particular point, which was what, 74, is that 74? I'm sorry, 73, 180 would be that point. So I'm going to choose 2 points on the line, and then I'm going to find my slope, use point slope, and let's see how close we got to the 178. It should be within the vicinity. So what do I need? I need 180 minus 170. I need 73 minus 71. That's going to be 10 over 2, or 5. That number again represents my slope. It's all staying together. All right, now I'm going to use my equation, my point slope equation, 5x minus x1, and then I just have to use one of those ordered pairs. Let's just use the 71, 170. Does it matter which one? Nope, not so much. Because when we put it in slope-intercept, it all comes out the same. Now I need to distribute. Add 170 to both sides. Okay, so negative 185. From here then, predict the weight of a player that is 72 inches tall. So 72 we know was the height, so that's got to be x. So let's substitute that into our original equation for x. And we look at that. 175, and again, our prediction was 178, so we did very well on that. Now that we have the equation, we can use that equation to predict the height of a player. Now, this is going to change just a little bit. Remember that this is sort of our guidepost, y is equal to 5x minus 85, but you know that the height, what was that? Was that the x or the y? I know you all are saying, well, that was the y. So that would be then 165 is equal to 5x minus 185. So now we're going to solve the equation a little differently. Pulling up my screen. All right, so I want to get x by itself, so I'm going to add 185 to both sides of the equation. 165 plus 185. And when I divide through, then x is equal to 70. Now let's see if that matches up. 70, 165 pounds, so 70 inches. And let's see if that matches up with our poundage. Let me grab a line again. If I go to 165 would be approximately here. Go down just a tad. 165, and then the question is, where would that meet my original line? If I go down from there, and I'm a little off there. It says, let me see, I'm not really calibrated very well. There we go. So looky there. Oopsie. So, oh, that just moved, but you get the point. It landed at approximately here to end with, and look at our prediction. It was 70 inches, and if we were just looking at the graph, we would have said probably about 68 inches. It does not have to be perfect. I hope that you enjoyed this lesson on drawing a line of best fit, writing an equation, and using the equation to help with your prediction.